All right, so let's finish up our lesson on nonlinear systems, or things that aren't just straight lines. And so we've got two examples left to do. One of them is going to be quadratic systems. So remember, in this quadratic, we're looking for things that have x squared, and this means we're going to end up having two parabolas. We also said earlier we can do completing this square, but you all decided, I think collectively, that negative b over 2a to find the axis of symmetry, and then to plug that in to find the y value was the easiest way for you to find the vertex for the parabola and then graph it. So this is just a reminder, you're going to do this problem to find the vertex, and then you're going to check for vertical stretches or reflections. Sorry, I can't write and talk at the same time. All right, and then we'll graph the 1, 3, 5, 7. And so you can write that down too, if that's helpful for you. All right, so I think I'm gonna go ahead and look at question 4 with you, just because it has kind of a thing that's missing over here. So we're gonna graph both of these. Remember, remind yourself that you're looking for a parabola and a parabola. That's what we're going for. And let's go ahead and do that first one. So I'm going to do, this is negative x squared plus 4. I'm going to have to change colors. I'm going to change this to black. One thing that's interesting about this is we're missing the middle. So this is the same thing as negative x squared plus 0x plus 4. So when I go to do opposite b over 2a, that's 0 over 2 times negative 1, which is just going to be 0. So now I'm going to plug that in. Negative 0 squared plus 4 is negative 0 plus 4, which is just 4. So I have a vertex of 0, 4. And then we'll do just a quick check of this equation. If I look at this original equation that I'm highlighting up here, I notice that it has a negative, so my parabola is actually going to be opening upside down. All right, so I'm going to come over here to my graph to plot this. That is going to give me a point at 0, 4 up here on the y-axis, and my parabola is, sorry about that, and my parabola is going to be going down, so I'm just going to go down 1 over 1, down 3 over 1, down 5 over 1, and I can't fit 7 on there, so this is what my graph is going to look like. Okay, and then let's switch over to this other parabola. So we're going to do the same thing. We're going to do opposite b. All right, so I'm using this one. Opposite b is positive 4 over 2a. A is 1. All right, this is going to simplify to give me 4 over 2, which is 2. I know some of you can skip that step, but some of you are still struggling with that, so that's why I'm writing it down. All right, now we're going to plug that in. So 2 squared minus 4 times 2 minus 2 is going to give me 4 minus 8. Sorry, this pen is being terrible. Minus 2, which is going to give me negative 6 in the end. All right, so I've got a vertex at 2, negative 6. And then again, we're just going to check my equation, not in that color, in blue. We're going to check my equation and see here at the front, there are no vertical stretches, and this is a standard parabola going up. So we can go ahead and start graphing that. So let's pop over here to our graph. We'll start with the point 2, negative 6, which is right here. And then we'll just go up 1 over 1, up 3 over 1. I already see one of my intersection points. Sometimes I help myself by like circling that intersection point while I see it. Up 5 over 1. Oh, and there's my next one. And I can do the next step, up 7 if I wanted to, but I see that I've already found my intersection point, so I don't need those exact points anymore. So remember, the last part of this, and this is the hardest part, I know this sounds silly, but it's like the hardest part to remember, is naming our solutions. So we're going to make sure that we name these. I see one of them is going to be at negative 3, negative 5, and that I have a second solution at positive 1, 3. All right, so this is what it looks like if we have two parabolas. Now we need to remind ourselves how to do exponential. And this set has two different kinds. We've got linear and exponential. So remember, just notes for yourself, linear is going to be y equals mx plus b. Sorry about that. And then exponential, we're going to have, it's going to be in the form y equals a times b to the x. And then you can make a note to yourself here that a is going to be your starting value, like your y-intercept, and b is going to be what you're multiplying by. And we reviewed today that if b is greater than 1, that's going to be growth. And if b is less than 1, that's going to be decay. And then quadratic, we already reviewed that on the other side. All right, so let's look at these. And actually, I think I'm going to do both of the exponential. I'm going to let you graph the linear and the quadratic on your own and see if you can name the solutions to these. All right, so this first one is actually a little more tricky just because of the numbers that we've been given. All right, so I'm going to show how would we graph this. So these almost make more sense if we use kind of a starting number. So my starting number is at 4, and then I'm multiplying by 3 over 2. So if I do that without a calculator, I'm going to multiply the top, and I'm going to divide the bottom. So if I do 4 times 3, that's 12 over 2. All right, which is the same thing as 6. All right, the next one is going to be 6 times 3. So times 3 over 2. That's going to be 18 over 2, which is 9. Now I'm going to multiply by 3 over 2 again. 9 times 3 is 27 over 2. Which doesn't divide perfectly, but that's going to give me 13.5, right? Remember, we can also go backwards. So to go backwards, we would just do the opposite of that. So we would take 4 here. I'm just kind of helping you understand the math here. We would multiply by 2 and divide by 3 if I want to go like backwards. So that would be 8 over 3 if I was going the other direction. All right, so to graph this, it's not going to be perfect. But we can get pretty close. So to graph this, we're going to start at 4 on the y-axis. That's right here. My next number is going to be at 6. My next number is going to be at 9. And then I'll be at 10, 11, 12, 13 and a half. All right, and then I don't actually think the next one fits, but you could multiply again to see if it does. Just so that you can see, I'll highlight the answers here, like the numbers here. Here are the numbers in this sequence: 8, 4, 6, 9, and 13.5. All right, so we've got a growth equation that looks like this. And so now you can take a second to graph the line that goes with this as well. And now that you've done that, we will check the solution for that when you come in tomorrow. So that's part of what I'm going to be looking for is, did you try that, like finishing the line in your notes? All right, and then question 6, we're going to do the same thing. I'm just going to do the exponential with you. So we're looking at this exponential equation right here. Again, this is going to start. This is my starting number out here in the front. So I'm going to start at the value 18. And this 1/3 really means I'm getting smaller. I'm so sorry, that color is hard to see. I'm going to be dividing by 3. This is like, basically I'm doing times 1, divide by 3. So 18 times 1 is still 18. Divide by 3 is going to give me 6. If I divide by 3 again, I get 2. If I divide by 3 again, I get 2/3. If I divide by 3 again, I'm going to get 2/9. And then to go, so all of this is multiplying, like dividing by 3. If I go the other direction, I'm going to multiply by 3, which I think is going to give me 56. That's a lie, 54. All right, so let's see if we can graph this one then. Remember, 18 was the starting point, so I'm going to start at 18. All right, which if I counted correctly is this dot right here. And then I'm going to go to 6. 1, 2, 3, 4, 5, 6. And then 2. And then 2/3, which is just going to be smaller than 1. And then 2/9, and they get really, really tiny after that. All right, so you're going to have this exponential curve that kind of comes down and looks something like that. Obviously, I can't fit 54 on the other side. All right, so again, I'm going to ask you to practice this part where you come back and you graph the parabola, and then you try to figure out what the solutions are for this one. All right, I will see you in class tomorrow.